very excited to hear what you have to tell us, Ryan. Go ahead.
Okay, great. Thank you. So thanks for inviting me. So this is a paper that started a while ago. It started with Colin and Peter and I being, I guess, somewhat dissatisfied with how habits are conceptualized in economics and marketing, and how versus how they're conceptualized in psychology and neuroscience. And so we wrote down a bit of a theory and did sort of a quite extensive review, I guess, and it ended up in a book chapter. And around the same time, Carice Zhao, who was a second year, or at the time was a second year PhD student and who's now graduated and going to McGill next year, she was working on her second year paper, looking at a downsizing event in the canned tuna industry and looking at switching behavior. And so when we saw this data set, it was pretty clear to us that we should put these together to try and test our theory. And so that's how this paper came about. It's been a couple of years in the making. We're still sort of in the middle stages, I guess, of our analysis. So we're really excited to hear feedback and see the reception. Okay, so what I want to keep, the setting I want you to have in mind is you're a shopper who's going to your grocery store. Maybe this is a grocery store you go to regularly. You have a list with you maybe, and on that list is canned tuna. And so the first time you go to buy canned tuna, you go down to the canned tuna aisle, you see all these cans. You might stop and look at them for a bit, maybe look at the prices, maybe you might even pick up a can and maybe see what the ingredients are. And maybe the second or third time you do that, right, you compare prices again, maybe you switch, maybe you don't. But eventually over time, maybe the 8th or the 9th or 10th time, you're gonna walk into that canned tuna aisle and you're gonna be like, yeah, I want the blue can on the second shelf. That's my can, pick it up and walk away. And then one day you're going to come to this canned tuna aisle and you're going to go and pick up your blue can on the second shelf, and you're going to literally pick it up and it will be a smaller size. In 2008, all the canned tuna producers, national canned tuna producers, shrunk the size of their cans from 6 ounces to 5 ounces. And this happened roughly in about the span of a year. All major brands did this. So you go one day and your can is now smaller, it's shrunk. So what do? Well, maybe you stop now and look at the other cans. And maybe now you look at prices again and sort of re-optimize your bundle. So that's the underlying intuition of the theory. And that's sort of the setting that we want to analyze. What happens to purchases, to switching behavior, if you like, after this downsizing event? Now, there's sort of a wide and implicit recognition that habits matter a lot in consumer choices. And there's sort of 2 features that we want to highlight that I think everybody agrees sort of make up the components of a habit and that we want to think about in the context of a theory of habitual choice. The first is that habitual behavior is persistent. So this is a quote from a 6th century Chinese philosopher. Obviously, the original quote was probably in Mandarin, and so somebody inserted the word habit into this quote. But the basic idea is that there's some persistence or automaticity in behavior that when you initially you might be thinking about your behavior, but over time, as you do it over and over again, it becomes automatic, in some sense becomes a part of you. That's the first component that I think we think of as about making up a habit. And the second, that there's some reason why we do this. There is some normative foundation for a habit. In particular, this behavior might allow us to optimize in the sense of conserving cognitive resources in our decision making when we put this type of behavior, some behaviors, onto autopilot or into a habit. Now, the standard way of thinking about habits in economics, though, we don't feel captures these 2 properties very well. So the standard model, the standard way of thinking about habits is as preference complementarity. So when you purchase something today, your utility for it increases, and so you're more likely to purchase it tomorrow. This was originally proposed, I think the standard reference is Becker and Murphy in their rational addiction paper. And the basic idea, it's been used many times since then, the basic idea is that past choices enter your utility function, and so that's what creates persistence. And there's been a number of papers in economics and marketing analyzing choices and finding evidence for this persistence. This is called the state-dependent utility literature. But the issue with this sort of conceptualization of choice persistence is that there is no role for cognitive effort or attention to alter choices here. And what I mean by that is if you look at this utility specification, yes, past choices might influence your behavior, but so do all the current observables in that period, in this case, X. So things like prices, things like quantity changes. You're paying attention to everything, not only of the good that you're choosing, but of all of the other goods. And so the way we want to think about habits is slightly different, and we want to compare it to this sort of standard state-dependent utility conception of habits. Now, I want to be very clear right off the bat about our conclusions. We are not going to conclude that state-dependent utility doesn't exist. In fact, our argument is that there are multiple forms of choice persistence, and state-dependent utility in our model lead to different types of choice persistence. And we're going to find evidence for both. So it's not that state-dependent utility doesn't exist. There are many good examples. There are many cases in which you might learn about your preferences or learn to appreciate a particular good. But we just want to separate our conceptualization from that and argue that state-dependent utility is not a good conceptualization of habit, at least as comes from psychology and neuroscience. Okay, so Colin gave a talk to this group a couple of months ago about this paper, and so I don't want to get too much into rats pressing levers. But I do want to just mention these two sort of standard definitions that come out of the psychology and neuroscience literature, just so that we're aware of them. The first one is the more psychological definition. Habits are a specific form of automaticity in which behavior is directly cued by contexts that have been learned to be rewarding. So an example of this might be you walk into your restaurant for lunch and you sit down and then you see the bar taps and you're like, oh, well, maybe I should get a beer for lunch, right? You're just cued by the context of being in a bar for lunch, and so you have a beer, something like that. The second comes out of this learning literature, and it's really been the focus more in neuroscience the past few years, is that habits are overlearned behaviors. So they're action sequences that are insensitive to reward devaluation. And what I mean by that is if you train a rat to press a lever for a reward, and then you then devalue the reward, so you make the reward taste bad, and the rat knows this, then when you put them back into the test situation in which they press the lever, they will press the lever more or the same amount if they've been trained extensively in this training phase versus if they've only had moderate training. So if you stick them in this training phase to press the lever a lot over a long period of time, when you devalue the reward, they still press the lever even if they're not getting anything. And this is interesting because the neural computations that we know are associated with this conditioned learning behavior have been measured in the striatum in the neuroscience literature. And so we're going to adapt those equations and sort of put them into a consumer choice model. And so now I'll just describe to you what that model is.
Ryan, can I ask a question?
Yeah, go ahead.
This rat example and I think in the way you described the tuna example at the very beginning sounds a little bit different. In the tuna example, you seem to be suggesting that when the reward becomes smaller, that is the size of the cans becomes smaller, that might trigger people to somehow pay attention to all the brands again.
Mm-hmm.
Right? But in this example, it seems to be suggesting, when you are trained, so often, even that you have some devaluations of the reward, the rat doesn't change the habit. Right? So just trying to say, if it may become clearer later, if that's the case, I can wait.
So I guess what's going to matter is how big the reward change is and whether that shocks them out of a habit mode or not.
Mm-hmm.
Right? And so I grant you in this devaluation experiment, like there's this persistence in this habit. Eventually they do over time stop pressing the lever, right? It just takes some time to get out of that mode.
Okay.
That we're going to allow in our model, that change is going to be conditional on it being big enough. It's going to happen right away.
Mm-hmm.
Right. So that's the different. That is going to be the one. We're going to make some changes from this standard, this conceptualization in neuroscience into when we integrate it into the consumer choice model.
Right, right. I guess here in this example, it's not like the rat has a choice of pressing another lever, another button.
I guess
or something.
I think what's striking about this experiment, though, is that this behavior is suboptimal in the sense of it's persistent, right? Like the something about the reward environment changes, but the animal is still choosing to press the lever.
Mm-hmm.
Ryan, maybe related to that, I mean, in the case of the tuna, I mean, is your argument here more that the reward became smaller, or any change in the environment? Meaning, I mean, there is this paper by JP and Bart, right, and others about moving to a different place in the US, and that's the reward may not change, but the environment changes.
Yeah.
You are being more for one or the other.
Yeah, it's going to be about the environment, right? So I'll guide you through the basic principles of the model, and you'll see that a lot of things can surprise the consumer out of habit mode.
But if it is the environment, then what's wrong with the state dependence model? Meaning, isn't that exactly it? Meaning the state dependence model says prior choices matter, possibly a lot, depending on the coefficient, and the environment are the other x's. So yes, if the other x's suddenly change, and I guess you would argue maybe these x's are not changed, but rather just maybe we should define them more as a change. Is that the direction?
Well, so in the standard model, behavior, the choice probabilities will change in response to any change in the observables, even when they're small. And in our model, they won't change when they're small. So that's where we're going to get identification between the two, is that in habit mode, there's small price changes, small quality changes don't matter.
Okay, thanks.
Okay, so we'll have two modes of decision making. One is habitual, which is going to be very simple. It's going to be automatic. You just repeat your choice. And the second will be a standard random utility model. So the consumer is going to learn and form predictions about utility. They'll enter habit mode when those outcomes are reliable. So they'll be calculating a reward prediction error, like in a standard learning model, and or reinforcement learning model. And when those reward predictions are small, they'll judge the environment to be stable, and they'll go into a habit mode, and they'll exit when they have doubt about those predictions. So when the reward predictions exceed some threshold. And this signal that we're going to be using, not only the learning signal, as I mentioned, has some neural signals associated with it, but also this reliability signal, this doubt stock that we're going to be calculating, there's been evidence for an unsigned reward prediction error in neural activity as well. And that's the component, this unsigned reward prediction error, that's going to make up our doubt stock. I'll show you the equations in a second to sort of formalize all of this. Okay, and then our questions, research questions, we're going to be focusing on three things. One is choice persistence due to automaticity or state-dependent utility, or both. So we're going to have ultimately, we're going to have a nested model here where we're going to be able to test between these two. How does the economic environment influence habit or not, right? Is this relationship between stability and instability in the environment jolting people out of habit? And then third, what is the proportion of choices made in habit mode versus model-based mode, and how might that depend on category? Now, the results we have for category are pretty new. Ultimately, we're hoping to test a bunch. So we have tuna, and we've also now looked at orange juice. But the idea here is that we can at least get some kind of metric across different categories to say, hey, this category is more habitual than this one. So related literature very quickly. The state-dependent utility literature that I mentioned, habits as rational and attention. So there are a few people, theorists, looking at this question of, can we write down a different model than state-dependent utility? So Jakob Steiner at Zurich has written down a model that uses his rational and attention framework, and our conceptualization is the same, is that when the environment is stable, you're not going to spend the cognitive effort to maximize utility and collect information. So you're just going to automate your behavior. And then third, there is this literature on forced experimentation, the London Tube study. There's another paper about natural disaster altering beer production in Brazil. And so looking at what happens when there's a change or a stock out of a product, what happens to experimentation and choices afterwards. Okay. So let me take you through the model. So the model has three components. The first are reward predictions. So for a consumer, they're going to track the utilities. They're going to learn about the utilities of the products they're choosing. Here we have consumer I, product J at time T. This is a standard reinforcement learning equation. If they're choosing the product, they're going to be learning about it. Otherwise, their predictions will just stay the same. So when rho is equal to 1, you just learn immediately. You learn your utility immediately. The second equation is going to be reward reliability. So here we have a reward prediction error that's unsigned. So this is the utility of the product you're looking at compared to your prediction. And you're going to track this in a doubt stock. And you're only going to update your doubt stock based on your reward prediction for the product that you chose last time. Otherwise, we're just going to assume that you add a little bit to your doubt stock. You can think about this as you haven't tested your utilities of the product you're choosing in a little while, and so your doubt about it is going to increase. Now, for the products that you haven't chosen, this equation, this part of the equation here is going to limit to alpha over lambda. And so that quantity is going to be important. So just keep in mind that if you haven't chosen something for a while, it's going to be increasing, or if it was high at some point, it's going to be decreasing to a number, and that number is going to be alpha over lambda. Otherwise, you just update your doubt stock for the product you chose previously using current period's utilities. Now, this is actually going to be an important piece because we want to allow current prices and the current size of the can to jolt you out of habit mode, right? So we want them to be able to pick up the can and be like, oh, wow, the can has changed. I'm going to now change my choices. So we're going to use current period utilities here, but only for the thing that they're choosing. And they ignore everything else. And then to close the model.
So, Ryan, just one clarification.
Yeah.
So here, the consumers do realize they take into account the size of the can and also the price that they pay in each period to get the current utility. Right? That's the assumption of the model. Okay. And that's the case even if the size of the can doesn't change. Price always enter the utility.
Yeah, we're going to assume that when they're picking up the can that they do see the price. I mean, I think we could eliminate that as well and only make. So the question of what goes in here in order to jolt people out of habit mode is an interesting one. So currently we're assuming that price does go in. But I mean, I would argue actually that maybe price shouldn't.
Yeah, because if you really say it's habit, then
right,
people may not even think about the price. I can see some people don't even think about the price.
The other thing that's not in here that maybe should be, so promotions and features we're going to include in utility. So if there's a big sign around the tuna, it'll go in. But promotions and features of the other products won't. So that's another thing that probably should at some point enter the doubt stock.
Yeah, I definitely think it's worthwhile testing it at least, right? Because, and again, I understand that from a maybe purist habit view, you would say, look, I'm so much in habit that I don't even look at other products. But, there is a big sign on the tuna right next to it, 50% off.
Yeah.
yeah, that's may jerk me off my habit, right?
Right.
At least empirically, probably would be worthwhile checking.
Yes, exactly. So I think, so there are a few possible specifications here for what goes into this U in the doubt stock. But right now it's prices and nothing, prices and can size, and anything to do with that product and nothing else. But I agree, there's a lot, there is some tweaks here that probably can be made. It's just a question of which ones, how to incorporate it.
Yeah, I think, and I would just comment on the idea of this doubt stock is also similar to some, rational attention models. Some of those models do not use the term doubt stock, but essentially build another stage of the model that determine how likely people will pay attention to other products. But I think essentially the idea is similar.
The rational inattention models?
Yeah.
Yeah, so I think at a theoretical level they are. I'm curious empirically, I mean, have people, I don't know if people trying to incorporate those empirical models.
Yeah, so Mike Keen and I and Tulin, we have a few papers that use a very simple I don't know whether we should call it rational intention, but it's sort of an attention model.
Yeah, because
yeah.
I mean, are you starting with an entropy objective function?
No, I mean, no, not that sophisticated.
Okay.
So I think it kind of, may have some similarity of what you are doing. But that's sort of, that we can incorporate some ideas what ODAT is suggesting. That, when other products categories, when other brands promote, features, then it will prompt this person to think about the whole categories.
Yeah, so I mean, ultimately, like in all those models, there's a cost of collecting information, right? And so I think that idea, incorporating that idea empirically is more. So if there are more papers on this, let's follow up because we can include those.
There's maybe another way to test this, which is we know empirically from many years of research and scanner panel data that cross-price elasticities do exist. Now, your model does not preclude them per se, because those are not in habits may have cross-price elasticity, right? However, your model, if I understand correctly, argues that if I am in a habit, I'm going to have zero cross-price elasticity.
Yes.
And I wonder whether you can see whether your model leads to lower cross-price elasticity than what we typically observe, or something along these lines to test it, because again, it's a strong assumption of zero cross-price elasticity for a certain group of customers. So maybe that could be a way to test it.
Yeah. So in the original theory paper, the one that went to the book chapter, there's a section we've written on price elasticities, including cross-price elasticities. But I do agree with you that I think in principle, this specification, the one that I'm showing you here, is probably making too strong of an assumption there. But it also makes statements about the size of what the price elasticity should look like depending on the size of the price change, right? So in this case, we're having, like I said, we have small price changes, we have no change in behavior, and then so there's also this difference between long run and short run price elasticities in the empirical literature, and I think the model can speak to that as well.
But if just to add on this, if I understand that it's comment, you're just saying that it's testable here, right? So your model predicts that if your current product's features don't change and prices of other products change a lot, the model predicts you'll never react to that unless there is some other shock which gets you out of the habit mode.
Yes.
And that's something you can directly test in the data.
Yep.
And some version of that actually seems really plausible here, that when the other tuna brands change their can size, if the change hasn't come to my preferred brand yet, it does seem plausible that I don't even notice. And actually, you can think of that as in some price per quantity that is a shock to price that basically very few people would notice, I would assume. I mean, I assume that, of course, everything happens in the data, right? But like the vast majority of people are not responding to the can size change by the other brands.
So this is the hard part, is we kind of have to like take a stance on what people should be noticing and what they shouldn't be noticing, depend on like ease of noticeability or something like that. Because I agree, that's probably going to be pretty innocuous if the other cans change. But at the same time, like if there's a big promotion around it, then it won't be innocuous anymore.
Right. If all of a sudden the other cans were actually a third of the size they were before instead of 1 ounce smaller, or all other cans are 5 times as large, right. I mean, clearly something has changed also about the whole visual environment.
Yeah. But I think Andre's point is a good one, is that ultimately all these are going to be testable, right? Because we get to define what this goes into this U.
Yeah, and then this is back to Andrew's point. You can now like reject some other formulation of the model, this two-step models of inattention, and maybe yours is better, maybe it's not. That we can there is something concrete we can say about it. Yeah.
Okay, great. So let me just finish closing the model. So you're going to be, if your doubt stock is below threshold, you're going to automate your behavior. You're just going to repeat your choices. But if you are above threshold, so you're out of habit mode, then you're just going to maximize utility. And the nice thing about this specification is that when theta is 0, we just have a standard model. When theta is not 0, we don't. And so we're going to have a nice test for this model, at least relative to standard random utility. And I guess the panelists have already kind of figured out some of the tricks or interesting features of the model, but this is a simulation sort of demonstrating them. We have 2 product choice here. In dashed lines are utilities and the solid lines are your predictions. If we have this consumer choosing between these 2 things, let's start them out in maximizing utility. So their doubt stock is above a threshold here in blue. The consumer will identify that product 1 is the best product and they'll choose product 1 for a while. But then if product 2, if there's a utility change to it, they don't notice it because they're in habit mode. Their doubt stock has decreased to below threshold. They've entered habit. Now they don't notice this utility change to the other can, up until the point at which the utility of the thing that they're consuming drops, their prediction drops. They go out of doubt stock, they go out of habit mode, and now they choose product 2 because it's better, and their prediction then increases up to the utility of product 2 because they are consuming it. So this value here is alpha over lambda. This is what the doubt stock converges to when it's not being chosen. I've drawn it here above threshold, and this is a desirable feature of the model because when we want consumers, when they exit habit mode, to stay in rational choice mode for at least a couple of periods, maybe. We don't want them to go right back into a habit, right? If the doubt stock was limiting to something below threshold, they would just choose something else and then exit right into a habit. We don't want that. Or at least that would be a weird feature of the model. So we're not going to restrict threshold to be below alpha or lambda, but that's going to be something that obviously we're going to look at for in the estimates. And just briefly for identification, I know we already kind of talked about this, but in habit mode, small price and utility shocks for chosen good do not alter the choice probabilities. And all price utility shocks for unchosen goods do not alter choice probabilities. But in a RUM, of course, both will. Okay, so a little bit about the data. In 2008, 3 major can tuna brands all reduced the size of their cans. This was an example of one of the brands from before and after. So I should mention that not only did the size change, but also the label change. So there might be some influence of the design that's sort of wrapped up in this size variable. We're going to use the AC Nielsen house panel, the KILTS data set out of Chicago. Our final sample has 627 households and roughly 12,000 purchase occasions. The data span is going to be from 2006 to 2010. This is around the downsizing event. We're going to define products as individually packaged 6 or 5 ounce cans of tuna. So these are the most popular 13 UPCs from the top 3 national brands and 76% of the market in 2006. So what we do exclude is store brands. And as for price data, we're going to pull that from the scanner panel. And we have the weekly prices as well as whether it was on feature or display. And we actually have this price data for longer than the data span for the product choices. And that's actually going to be important for one of the for estimating initial conditions. I'll mention that in a bit. And then we do have some exclusion criteria. The consumer must choose exclusively from the UPCs chosen. So we don't, if they choose a store brand or a store brand at some point, then they don't go into the panel. And we do require at least 3 purchase occasions in each year. The selection criteria probably matters a little bit, right? Because obviously if we're choosing people that are buying tuna every day, they're going to be different maybe than people that aren't. I guess the idea here with 3 purchases each year is we want to exclude the people maybe who are only buying it like once a year at Christmas to make their tuna casserole. We want to at least be able to have a few purchase occasions during the year. But this is one issue with tuna, is that some people just don't buy tuna very often. Here's a description of the histograms for the canned introduction across the 3 major brands. And you can see this is all taking place roughly during 1 year and at roughly the same time. That is not probably a coincidence. For those of you who want to read up on the canned tuna industry past 2010, you may. But basically what we want to capture here is the idea, first of all, that there's some variation across stores and across brands. But this is all happening at roughly the same time. Here's a description of market share. And the diamonds on this plot show the date of the first can introduction for these brands. And so what I want to get across with this graph is relative stability in the market before the can introduction. And then something happens. Cans get introduced and market share changes. There's also a considerable price change at the same time. Prices went up around after the time of the can introduction. Just to sort of like provide at least brief background, the reason that cans change is because there's a shortage of tuna worldwide around this time and due to overfishing. And so that's probably one reason that cans got smaller and prices went up, or at least it's one reason. But again, what we want to get across is that there's maybe some relative stability in prices, and then afterwards, a little bit less stability. Okay, so let me start by showing you some reduced form results before we jump into the.
Ryan, just a question about the data. So I'm just imagining this shock, right? I mean, I go to the supermarket, my brand is only 5 ounce, and I'm looking around, right? Now at that point, it's likely that at least few of the brands have not yet moved, even though it's somewhat around the time, unlikely on the same visit.
Right.
Do you know anything about the prices? Meaning, because one of the reasons why they often reduce the size is that they can charge the same price for a smaller size. So now I feel also cheated because you didn't really reduce the price, you just reduced the size. Do you know what happened in terms of the prices of those who did reduce? Did they keep the price about the same as the 6 versus now it's equal to the or similar to the size to the ones who did not reduce yet and so on?
That's a good question. We haven't looked at specifically whether or not how can introduction date is correlated with price changes. I mean, this is the period, if you can see my cursor, from July 2008 to July 2009 for the introduction. And so there is initially a pretty big price increase around the time of this is the first brand to move, and these are the second. And if you compare to
Is the
history,
price per ounce of overall price?
that's a good question.
I mean, hopefully price per ounce. Otherwise, it's really double whammy. And
It's a real double. Yeah, I'd have to double check that. Oh. Price per can, says Clarice. Saved by the online seminar. Price per can.
wow. Okay.
So it is price per can that enters the model, or price per ounce that enters the model?
Price per can enters the model.
Okay. But it is interesting to, I think it's still an empirical question,
Yeah.
right? To which one is more salient to the consumers?
And specifically the contrast on the first day in which it happened, when I noticed, right? And suddenly I noticed that another brand is still 6 at the same price, or maybe even lower price, which would be even worse, right? And I think that it's important to kind of understand that behavior.
Yeah, like maybe they lagged it by, a month or so. Like the supplier, maybe they're just like, well, we'll change the can first and then the price second. Okay, so I'll show you first, some reduced form results. So what we're going to do now is we're just going to look at around the time of the introduction. We're going to split the sample into 3 windows. Window 1 is going to be before the first can introduction, window 2 during the introduction, and then window 3 afterwards. During introduction, meaning 1 can has downsized, and then afterwards, meaning all 3 cans have downsized. And then we're going to define habitual consumers as just people who 95% of the choices in window 1 are the same brand. And we're going to do this because we want to look at differential effects on the people who are really persistent versus not. And so just the regression we're going to run is a standard regression on lag choice, conditional on habitual or not and window and the interaction, and then also looking at price sensitivity, again, for these across these subsamples. So I want to draw your attention first to the lag choice parameter. So these are the people here. You can see my cursor. The first lag choice variable are the people who are not defined to be habitual by us, and they have a significant lag choice parameter. So there is some persistence in their choice. But then during the can introduction, that drops. For the habitual people, they're obviously going to have a much higher estimated lag choice parameter because we've defined them to be more persistent. But that also drops. So we see far more switching behavior across both habitual and non-habitual people during and after the can introduction. Okay, so people are switching more. The second thing, if we look at the price sensitivity, P here is the price sensitivity for our non-habitual people. They're price sensitive. We expect that. Our habitual people are not. Again, we've defined them to, in some sense, be highly persistent, but we're not finding them to be price sensitive. But if you look at the habitual people in the second and third window, they become price sensitive during that can introduction. So not only are they switching, they're switching and they're looking at prices, whereas they weren't before. Okay, so that's just our two, from reduced form results, we'll just take away 2 summaries. One is that we see more brand switching behavior during and after the introduction, controlling for prices, and then habitual consumers become price sensitive during the introduction. Okay, and then now we'll go to the structural model.
Ryan, just about the latter behavior, the price sensitivity, this could be now given the price increase, we don't know if it's actually the size of the price, since both have changed around the time from your model-free graph.
Yeah, so I mean, the change in the persistence, the change in the lag choice parameter is controlling for prices, right? So that's our.
I mean, the first bullet point is definitely there from the data. I'm just saying that there is the reason for the second one could be because of the size or because of the significant change in price, right?
I mean, are you thinking about a reason for why they become more price sensitive? Is that what you're trying to explain?
Yeah, I mean, two things seem to happen at the same time, which is the size shrank and the price increased.
Yeah.
And I don't know which one is the one that snapped them out of their habit now. And particularly the price sensitivity may signal that it may have been the price increase.
Yes. All right. So we're going to be able to, I mean, both are going to enter our structural model, and we're going to be able to distinguish them, at least in terms of how they enter utility. And we will look at, some of the other observables that we're going to have enter utility. In particular, is going to be the new can arrival month. So we're going to essentially allow a dummy variable to pulse that first time they see their can change, as well as the size of the can enters utility. But all of these things in principle, including price, can jolt them out of, if they move, can jolt them out of the habit. How to test? I mean, I guess we could drop them from utility, but then of course we're dropping them from utility when they're maximizing utility too, right? So I don't know if we can say whether or not it was the can size or the price change that jolted them out of habit, but it was one of them.
Yeah, unless there is a time difference between the two, that may help.
Yeah, I guess, because for that particular, that particular timestamp when the can size change, which you also see more dramatic change in prices, then it seems clear you have an identification problem there.
So if the main point is to try and say, yes, it was the can, or yes, it was the prices, I agree.
Mm-hmm.
But I think our main point is that the economic environment changed, and that's what jolted them out of habit.
Right. Yeah.
And we will be able to test that statement, and we will have a model to test that statement, which, I mean, at least in my mind, is the more important one, than whether it was a can or a price.
Mm-hmm. Yeah.
But
I guess there are price movements, right? Even during the period that the can size is stable.
Yes.
There's always this temporary price cut that's happening. And if the data shows that just those temporary price cuts doesn't snap people out of the habit, then it seems to suggest it's more to do with the can size. It could be that the can size triggered the people that pay attention to more things, and they realize that price also increased a lot.
Yeah.
Right, but previously they're in the habit mode, they don't pay attention to the price at all, maybe. So even the temporary price cut, they're not sufficient to snap people to take them out of the habit mode.
Yeah, I think there's a lot of ways in which we can, like I said, there's a lot of ways we can specify that second equation.
Yeah.
And not use full U. That's another good one though. Okay, and then we're going to put random coefficients on product dummies, price, as well as our threshold parameter. I'll show you one without random coefficients just for interpretation. It'll be the easiest to see first, and then I'll show you the one with random coefficients. I don't want to get too bogged down in terms of likelihood. We only have 13 minutes, but there's an issue. There's a threshold, so we have to do some importance sampling to get around that. And the second is that the initial doubt stock is hard to estimate. And so we're going to use the price sequence from prior to give it at every evaluation of the likelihood. We're going to use those estimates or those parameters to generate whether or not the person was in habit mode or not, or based on the price sequence. And that's what we're going to use to start the initial doubt stock, instead of assuming that everybody's not in habit or everybody is in habit at the start of the sample. Okay, here's the non-random coefficients estimates. Model 1 and Model 2 are sort of a standard logit. The second has some lag choice parameter in it. Ignore column 3 for a bit. Column 4 is our base autopilot model without lag-dependent variable ending utility. I guess the first thing to notice here is that our threshold is high. It's bigger than 0, right? Which is our standard, our test for whether or not we're actually adding anything interesting to the model. We are getting a significant effect of the new can arrival month. So this does appear to be jolting people out of habit. The second thing to look for is this alpha over lambda quantity. It is higher than the threshold, which is nice because it means that people are limiting to something that when they switch, they're switching out of habit mode. Our preferred model is obviously model 5. It's the one that fits the data best. It is also quite significant when we add lag-dependent choice parameter. We do see it improves the model compared to specification 4, but the lag choice estimate is about less than half of what it was in the other, in the logit with lag choice, right? So the degree of persistence that is being picked up by state-dependent utility drops when we introduce our habit mode. Now, model 3 is interesting because it allows us to test the idea of whether or not the changes in the environment are what are jolting people out of habit mode. So this is a mixed logit in which we're just going to allow people some probability that you're in habit mode and some probability that you're maximizing utility, but it's independent over observations, right? So you're just bouncing back and forth between habit and maximizing randomly. And the comparison here with our autopilot model is our autopilot model, based on prices and based on the sizes of the can and other things, is specifying when you are in habit mode. You're in habit mode when the environment is relatively stable, and you're maximizing when you're not, when it's not. And so this is, I think, that the key test for the argument that the observables of the can or the product are what is jolting people up. The changes in those observables, big changes in those observables, is what's jolting people out of habit.
Ryan, can you explain the intuition why the threshold value in model 5 is higher than in model 4? Because I would assume that threshold value means there is more observed inertia in this consumption. And I would think that once you add the lag choice, it should go down.
Yeah, so the doubt increment also goes up a little bit,
right?
But yeah, so but that, I mean, that is a good point that I guess, right, we should expect it to go down a little bit.
I guess like this is just based because the argument between model 2 and model 5
because it's
was
picking
that
up
once you do
persistence.
this, yeah.
That would otherwise be assigned to habit mode. And so we should expect it to go down a little. Yeah, that's a good point. Let's see what happens. I'll see if that stays same in the RC, because really, I mean, I think the random coefficient specification is our preferred one. Okay. Well, let's look at it directly, actually. Yeah, same result, basically. we see a higher threshold. We're going to put random coefficients on the threshold, the price, and we see that the mean actually does go up in the second specification too. Interesting. All right, let's think about that. And there the delta increment drops a little bit. All right.
I would also suggest, Ryan, here to add mixed logic everywhere, right? I mean, even for the state dependence, right? Because one argument could be that what the habit does is capturing more heterogeneity.
Yeah.
So you want to make sure you give the full heterogeneity benefit for all models.
Right. Yeah, that's a good point. We should have done that. Okay, otherwise, I mean, I think that the story is roughly the same. Our drop in the lag choice parameter is roughly on the order of around 30% now. So it's not quite as big as it was in the estimate specification of random coefficients. Here we have size entering significantly. So the can size change is one of the factors, at least, that's entering utility and presumably shocking people out of habit mode. Okay. This is the density of the theta, and here I'm plotting the dashed line. This is the alpha over lambda, so this is roughly the same statement I made before, that most of the time that the doubt stock is limiting to something large relative to theta, which means that when people exit habit mode, they're exiting into rational choice. And then what we can do is, recall this equation here is the equation governing whether or not people are in habit mode. Given the estimates, we can simulate the probability that the doubt stock is less than theta. And we can look at that, we can simulate that for every period and look at the proportion of habitual consumers in every period. And so the first line here in green is the model without random coefficients. Our preferred specification is the one in light green, which is the model with lag choice. And in gray here, I've denoted the date of the first can introduction. And we see a drop in habit mode across all three specifications. Our preferred specification has about 12% of people in habit mode for canned tuna, and then a drop to about 9%. So whether or not 11% and 9% is big is, I guess, it depends. The argument, I guess, that 11% of people who are just automating their behavior is big if you're trying to sell to those people and you want to, in some sense, capture that portion of the market. And then we see roughly a fifth of those people exiting habit mode when the can size changes. Now, there is some issues with tuna for analyzing a model like this. One of them is that people don't tend to buy tuna really frequently. And so we wanted to look at other products. And so one of the products we thought about was orange juice. Now, I mean, products, there's a couple of different criteria they have to fit. One, hopefully that they're chosen quite frequently. The other is that there's only a few major brands. We can't have too many products to look at. So orange juice kind of fits this bill. We're looking at individually packaged 64 or 59 ounces a bottle of orange juice. There was actually a downsizing event in orange juice around this time as well. It's just it wasn't as isolated as in tuna. Like for the tuna category, it all basically happened within a year. In orange juice, it happened sort of much more willy-nilly across brands. And our selection criteria is looking at least 6 purchases in each year. Now, again, the selection criteria is going to matter here, as well as the date range. So we're looking at a much larger date range, which means that we're going to be excluding more people in this sample. And so I think ultimately we want to be looking at the same date range and with the same selection criteria, although of course it's all relative, right? Because I mean, how often do people purchase orange juice relative to tuna? Sort of probably orange juice more often, but
And you have 3 minutes left. So
all right.
just warning.
So here's the estimates from orange juice and tuna. I guess the one thing to note is that the estimates for the the habit model parameters are roughly the same across orange juice and tuna. So the threshold is roughly the same, the doubt increment is roughly the same. So it seems like we might potentially, at least in these two categories, picking up something about the reliability signal that these people are using to govern between the two modes, at least that are somewhat consistent. What is different is that we see more people in habit mode in orange juice. Again, this might be partly due to the sample selection criteria, but maybe also because it's just easier to form a habit for things that you buy weekly as opposed to maybe monthly. Okay, so just to conclude, we integrate a neurobiologically founded model of habit into a consumer choice model. We see strong evidence for choice persistence arising from our habitual autopilot model. Roughly 11% of tuna choices are made in habit mode, with a drop to 9% after the can change. These habitual choices do not use all available information, sort of by definition, but also don't require a lot of effort. So they may be rationally attentive in the sense of they may actually be optimal. The magnitude of previous choices in utility, the lag dependent utility parameter, drops by roughly 30 to 50% when we move to our include a habit model, This means that there is still a role for state dependence. So we're not saying that state dependent utility doesn't exist. It's just that it's picking up a different form of choice persistence, and that we argue that it's not a great conceptualization of habit, at least as conceptualized in psychology and neuroscience. It might be something else. And finally, just a point to think about, in habit mode, demand is inelastic for small price and quality changes. And these changes decay, right? There's depreciation in your doubt stock. So what that means is many small changes are not equivalent to one big change. And I think thinking about other examples of markets and promotion strategies where that occurs might be an interesting area for future research. So thanks everybody for your comments. I got a notebook full of them. And it was, thanks for having me give this talk.
Thanks for coming, Ryan. So if anyone wants to ask additional questions, feel free to raise your hand and we'll promote you to being a panelist.
I guess, Ryan, an alternative explanation of what you're finding could be that it's not that they notice suddenly something in the store, but there is a lot of popular media talking about how tuna prices or the great tuna, whatever scandal, which explains this change of habit. I'm not sure if it matters that much for what you're trying to say, but it matters a little bit, right? It's not that their habit changed because they saw something on the shelf, but because they found out about this big issue or something.
Yeah, so that would definitely probably be confounded with the size variable, because like size is also essentially a dummy for before can change and after can change.
Right.
But new can arrival month, although
yeah, but those were never significant, right? If I read,
they were in the non random coefficients, but then in the random coefficients they did not. They went away. So potentially yes, yeah. It would, yeah.
Ryan, I'm trying to think, how, what data variations allow you to identify this alpha term, the increment parameter, even if someone didn't see a shock.
I missed the first part of the question. What?
So alpha, basically, my
What
question
data
is,
variation?
yeah, what data variation allow you to identify alpha? I guess intuitively, the model would say the longer people haven't changed a habit, the more likely they will just, okay, maybe today I should try to re-optimize.
So do you agree that, do you agree with the basic logic that small changes in prices here won't matter, and small changes will in the random utility model? So then the question is, I guess you want to go a layer deeper and say, okay, conditional on, we know that we have identification due to small changes. Why is it specifically alpha versus the threshold? And because ultimately alpha over lambda is what is driving that, whether or not they're in habit mode or not when they exit, right? So that's going to determine if alpha is small or lambda is large, they're going to exit right into a habit. Is that your concern?
I guess I'm thinking, maybe now it's the down stock that determine whether you want to get out of the habit or not.
Yes.
Right, and the down stock, even there is no change in can size or no change in price, it will be accumulating over time because of the alpha.
Yeah, so if for the thing that you don't choose, doubt stock will increase, or in this too good example, will decay to that level.
Can I just look at the equations about how the doubt stock? Yes, yeah, this one here. Okay, so the lambda is the depreciation. Let's see. Okay, so it's relative. Okay, I think I see what they're saying. Okay.
I think, Richard, maybe you had another question?
Yeah, thanks. Just a small one, Ryan. I was wondering if you can calculate the correlation between the frequency with which consumers make tuna purchases and the frequency with which they're in habit mode. Just sort of wondering if the people that are frequently buying tuna are the ones that do so with habit.
Yeah, that's a great idea. I guess ultimately you only have a distribution of consumers. So I'm not sure that we can actually test that, because we can't label somebody as being in habit mode or not at any specific time. Or we can say something about the distribution of consumers, but we can't say something about a specific consumer. But I think that's an underlying theory, like that's entering the underlying theory of the model, is that people who are consuming more often, at least a specific brand, are going to enter habit mode easier.
Yeah.
We really would need an individual estimate, though, of whether or not somebody is in habit mode at any specific time in order to test that.
You couldn't look at the divergence between the two distributions, something like that?
Which two distributions? The
habit mode and the frequency of tuna purchases, or something like that?
Yeah, I'd have to think about that.
Okay.
It certainly seems like that would be a nice thing to have in the model, in the sense that if you were to imagine, targeting interventions at people based on the mode they're in, you might want to have some distribution over what mode somebody is in.
Yeah, I mean, all that we can really say is, we can say if you've experienced a relatively stable environment, you should be in habit mode.
But I guess that you can read some of that, what relatively
Oh.
stable is, you can read that off of the model. So
Right, that's
did you
observables.
experience a utility shock of some, some size, I guess, whereas,
Right.
and what that threshold has been hit to, I guess, fit, what the threshold is.
Well, I mean, I guess that's ultimately, that's another question of maybe what enters utility. Like, we're not distinguishing between people who purchase a lot and not a lot, right? That's not something that's entering the model.
And I think that's relevant, Brian, on the definition of habit, right? I mean, some people define habit more as a repeated in a fairly similar manner, meaning every X weeks, right? Versus, and specifically with the scanner panel data, people have been, when talking about habits, right? I mean, you may want to try and see if there is also some habitual behavior on the quantity being bought and maybe the inter-purchase time.
Like a systematic pattern, essentially.
Yeah, we just make sure we always have tuna in the house versus those who more like, yeah, once in a while I buy tuna, right? Which, even though I always buy the same, it's a different form of habit, arguably.
Yeah, so that brings up another issue with tuna, which is stockpiling, which is another reason why we like to go to orange juice, is because you can't stockpile orange juice, at least. For a long time, we were thinking milk would be an ideal category, but the problem is just there's too many brands. And there's no national brands, but orange juice kind of has that nice feature of it expires.
Yeah, on the other hand, with orange juice, you may have more opportunities for, I bought it because I have a party. I bought it because, or again, less maybe with tuna, if a recipe calls for something, right? So I'm not generally buying. So again, it gets you out of habit in terms of more the mode of purchase, but it still could be that the brand is very habitual in the sense of, I don't think about which brand to buy.
Yeah, that's a good point.
Cool. Well, I don't know if there's any further questions, but I think this was really interesting. And I'd say, actually a very nice compliment to the earlier talks this term, both by your co-author and then also, JP's talk for that matter as well. So maybe in this case, the repeated consumption is due to complementarities in our utility function here.
It exists. It exists.
Yeah. Anyway, very, very cool stuff. Thanks a lot. And thanks everyone for chiming in as part of the discussion.
Thank you all, and thank you, Ryan.
Thanks, everybody.
Yeah.